Okay, so we've got 2 points suspended in the room, and we have determined that they are at the locations that are given here. Normally we write these as 2i, 1j, and 2k. A lot of times you write them as a column vector, so -2, -1, 2, and this one will be 2, 1, -2. If we wanted to write it with i's, j's, and k's, we could write it with a plus in between and call this vector y for yellow and this vector p for pink. Okay, so I asked, what is the vector that goes from the pink point to the other point? So right away, I hope you knew that you just start with the starting point, which was this one, -2, -1, 2. And then you just put plus lambda and then the other point, right? No, that'd be great if it was that simple. The other point, we have to figure out what to put here, here, and here so that it will eventually get to this other point. In fact, the way we define it is that it will get to this one after one step. Like that's lambda is just going to be 1. So it has to go from -2 to +2. And so it's like, how far does it have to go to get there? And that would be a 4. Another way to think of it is you just take 2 minus -2. And 2 minus -2 makes +4. I'm just do the other ones that way. 1 minus -1 is like 1 plus 1, which is 2. And then last would be -2 minus 2, which makes -4. All right, now, if you were capable of flight, if you were going to fly from this spot to that spot, could you follow this route and go from my starting point? Could you get the door? He's going to go past him. Go from -2 and go up 4, right 2, and then back 4. Yes, you could. But that would definitely be the long way. The total distance it would take you to get there would be 4 plus 4 is 8 plus 2 more is 10. It would take you 10 feet to get from this pink ball to that yellow ball. Do you get how they're not 10 feet apart? But you're forcing the person to go 4 feet this way, 2 feet this way, and then 4 feet that way. Do you get how that's about 10 feet? Okay, now would you actually go that distance? No, you would take the shortcut. You take from here to there. So it's again, it's like a vector that starts here and goes there. All right, so I'm just trying to explain to you what this is. This is kind of a distance right there, the 4, the 2, and the -4, but that would be the long way. The hypotenuse that goes between them, it's kind of like the hypotenuse on a triangle, but now it's not the hypotenuse of a triangle anymore because it's got this 3 dimensions thing. So I decided to make it for you. People at home, you're not going to be able to see this, but I'm going to hand this around. And you've heard of the 3, 4, 5 triangle, right? And you can double it, of course, and make the 6, 8, 10 triangle. And then there was the 5, 12, what's another 13, 5, 12, 13 is the Pythagorean triple. Well, when you're in 3 dimensions, it's not the Pythagorean triple, but it is Pythagorean. But it's not a squared plus b squared equals c squared anymore. Now it's this x distance, which is like I, and then j, and then k. So you could almost say it's like a squared plus b squared plus c squared equals d squared, which actually works really well because isn't it a distance between here and here? So a squared plus b squared plus c squared equals d squared. So then it's the square root of, because to get the d squared fixed, you got to take the square root. So it's the square root of a squared plus b squared plus c squared, which is this number. That's how far you move in the one direction, and that number, and that number. So 4 squared and 2 squared and 4 squared, and you put them all together. I'd like you to actually figure that out, please. Figure out what it comes out to. You're not subtracting anything. because remember, these numbers are going to get squared. So even though there's a -4 in there, that's getting squared. Okay, gentlemen, I asked you to do something. Okay, excellent. Then don't distract the people behind you. All right, when you had 4 squared and 4 squared and 2 squared, did they add up to something nice? What is it? 36. That's because, relatively speaking, it's a Pythagorean triple, except it's not a Pythagorean triple. It's a Pythagorean quadruple. And it's based on, you know how there's the 3, 4, 5 triangle when it comes to the normal triangles? This I made, and it's got the dimensions of going over and up and out towards you, for instance. Okay? And it's got 2 and 2 and 1 going with 3. So instead of the 3, 4, 5 triangle, this is the 2, 2, 1, 3. But it's not a triangle anymore. It's in 3 dimensions. But if you take 2 squared plus 2 squared, what do you get? Square root of 4, or square, sorry, 2 squared is 4, 2 squared is 4, 1 squared is 1, 4, 4, 1 makes 9. And then that works out perfect because the square root of 9 is 3. All right? So some of you were saying that it didn't make much sense to you to have to take the square root of 3 things. And this is just giving you an example. I'm going to hand this around with a ruler. And I want you to see I actually made it proportional. So I didn't want to make it 2 feet long by 2 feet long by 1 foot because it'd just be too big, clunky, and probably break in my car and stuff. So I made it 2, but I made it 2 what? You know what those things are called? Decimeters. Good. And they're so basically it's about 8 inches long on each side, but 8, 8, and 4 isn't going to be not as nice to work with as, again, in millimeters. You could go 20 millimeters, 20 centimeters, thank you, or 200 millimeters. But anyway, this is proportions. You're used to that anyways on the 1, 1, root 2 triangle, for example. So anyway, I want you to see that this actually works, that the distance, you could walk this way, and this way, or you could go the shortcut, which is that way. All right, so I'm going to hand that around, and here, I'll send the ruler around with it so you can see the lengths. Now, the next thing I want to talk with you about is if we know the distance between these 2 points, then once I have the distance between them, I can figure out things like the speed. To get from here to there, if I was a bird and I was capable of flight, I obviously wouldn't fly over and up and then back. I would just fly straight there. I take the shortcut. So I get the distance. I'd like you right now to figure out what the distance is I already did it, but this is in feet, so therefore it came out to square root of 36, which was 6 feet, okay? And let's say that we do that. Do you agree that a bird could fly from here to there in like a half second? Okay. Then let's figure out how many miles per hour the bird is traveling. First, you got to figure out how many feet per second it is. We said it would be a half a second. It all comes down to distance equals rate times time. And if we want the rate, we're taking distance divided by time, which was distance 6 feet divided by time. What was time again? Half a second. Flip and multiply, and all of a sudden you got 12 feet per second. You're an honors freak out. Figure out miles per hour, please. Use a calculator if you want. You know, in the past, distances were a lot simpler because you just it said, well, how far did he go? And now we got to say it in 3 dimensions. It's not so easy to just say, oh, he went from here to here, so that's 10 feet. You got to be able to say, well, he went from here to there in 3D space, and then you got to figure out the distance. It's not that bad once you realize it's just the square root of a squared plus b squared plus c squared. Yes. 5,280 feet in a mile. But I know in the real world you could Google that, but if you were actually to know it in your head, it'll make you seem smart. I strongly recommend memorizing 5,280. Would you agree that there's a few basics that it'd be smart to have memorized, like how many days in a year? Don't have them memorized? All right. I don't think you're going to be asked or need the number of minutes in a year that often, but I happen to know it because of a musical. 525,600 minutes. Comes from Rent. Anyway, but you could, obviously, it'd be nice to have everything memorized. Somebody just asked, well, I know that. That'd be great, but you got to save your memory for certain things that are most important. I would say just the number of feet in a mile does come up a fair amount, so it's worth memorizing. 5280. All right. So I hope you multiplied by a few things, like, for instance, that. I'm writing out the number of minutes in a year. Okay, gentlemen, you're talking at a bad time. Please stop. Thank you. All right, so this is 5280, and this was seconds. So this is feet in a mile. And now I've just changed it to miles per second. And then you want to go directly to how many seconds in an hour. Awesome, that'll be a little faster. Cancel, cancel. And now I have miles per hour, which is 12 times 3,600 divided by 5280. All right. What does it come out to? It's about 8 miles an hour. Do you believe a bird can fly that fast? Yeah, very, very easily, probably. Well, peregrine falcon is one of the fastest out there, and they can fly. They do fly, but I know you were about to say, you're predicting what I was going to say. I was going to say that they can fly at like around 196 or something like that miles per hour, which is insane. But yes, that's achieved mostly by dive bombing. So think about that. If you're just like free falling, total pure free fall with no, like if you're just a bowling ball, it's about 200. Whoa, goes about 200 miles per hour. So, oh dear, you're gonna have brain damage from that. Hold on, I'm gonna pause for a second. So I have now got my I figured out my speed in miles per hour from having 2 points. Now, what would be more complicated than that? Well, there's a lot of ways to make it more complicated. But for example, let's say that at this moment, there's a plane that is in this location, and it is heading this way. Can you picture that? It is not heading towards that point. It's heading that way. Do you get, if I took this and then pointed it maybe over this way, that I could make a path where the two planes might collide, but it's not like right between them? It's heading opposite directions. All right, that's what you're about to do next. So I'd like you to take last night's homework out, and I didn't actually assign this problem to you in last night's homework because I felt like it would be just too much without having a good, healthy explanation. So I've given you a good, healthy explanation, and this is the part where you need to work with a partner to figure out the answers to a few more challenging questions. All right, I'm going to move this thing. First one here, find this on your iPad right now. I'm going to ask you to show me in a moment that you're there. It's right after where your homework was completed last night. It's the next page. Okay. In this question, distance is in meters, time is in minutes. That's important because when they ask you to find the speed, you're of course going to take it in meters per minute. And I'll be fine. I'm okay with you leaving it in meters per minute. I know we could, using stoichiometry or dimensional analysis, we could change it to miles per hour, but it doesn't say you have to. So you can do it in feet per minute or meters per minute. Two model airplanes are flying in a straight line. The first model airplane is at the point 327. Its position vector after t minutes is given by this. I really need you to understand where it is right now, which is what? Say it in three numbers. 327. Okay, now in the room, where would that be? Number 3. Up to back 7. All right. And then, what does this mean? Where is it heading? Do you get, if it went the slow way, it would go 3 feet to the right, and then it would go 4 feet, what does that mean? Up, and then it would go 10 feet further back that way. But would you actually fly it that way? No, you would actually take the shortcut, right? So do you get that if you take the square root of these, you're finding, all squared by the way, you're finding the distance that it goes in how long? What's t under that assumption? 1. So do you get to find speed? You just need the distance it went, and then it happened in 1 second. How do I know it happened in 1 second? Because if I put in 1 here, I'd like you all to do that. Put in 1 and tell me what you get when you put in 1. 6, 6, 17. This started here and it went to there. Now think about it. What's the distance between them? How far x-wise is it? 3. How far y-wise is it? 4, because the distance between 2 and 6 is 4. And then the last one is this one, which is 10. Those are distances. But you wouldn't take the slow way. You wouldn't actually go this way and then that way and then that way. You just go direct. And therefore, it's not 3 plus 4 plus 10 is not your distance. It's the square root of that. All right, I just wanted to talk you through that. So then the speed will be really simple because you already know the distance, or at least I told you how to find it. And then the time is in 1 minute. Again, if you don't believe that, put in the 1, figure out where it is. You'll see, oh, turns out the distance comes down to these 3. And the distance in 3D, you take the square root of that. All right, now you've got another plane. And then the airplanes meet at a point. And then what is that point? And then what time do they meet? Obviously, it'll be t equals whatever. Notice that this one has the same counter as this one does. The t's are the same. Okay, so they come out to the same. They come out to a nice number. It didn't even make it very messy. It came out to a nice number like 23. Okay, you're going to figure out the time, and you're going to figure out what place do they meet at. Again, a reminder on this. How do you find how this and this meet? Well, they're going to be meeting at the same point, right? So their x and their y and their z will all have to be the same. So you can write equations for that. Okay. I'm going to have you work with somebody. You're going to push together with the person next to you. It will help a lot to have somebody to work with on this. I'm going to pause for a second while I get you in groups now. All right, so some hints. Kids got stuck mostly on C, and where they meet is a really important thing. Would you agree that this one has an equation for x of 3 plus 3t? You get where I just got that from? Look at it closely. Can you see where I would have gotten x is equal to 3 plus 3t? Then look at the other one. What do you get for x? Negative 5 plus 4t. And if this one's x equals this one's x, do you get that that will have to equal that, and therefore you can solve a little equation? And you know that t comes out to something. Don't say it, solve it. All right? The last thing is, do you remember finding the angle between two, between two vectors? Okay, just a quick reminder, here's the formula you got to know. Cosine of the angle is equal to the dot product of the two over the magnitudes multiplied. All right. The magnitude of the first one, the magnitude you already have for that first one, and it turns out to be 5 root 5 for the first one, which again came from the square root of that squared plus that squared plus that squared. Okay, how many of you got that? Maybe you didn't simplify it, but do you get how it would simplify down to 5 root 5? Okay, you got to stop talking. Sorry, I'm talking right now. So when you're talking out loud, it's really distracting. All right, so moving on to the, I'm sorry, I tried to say it a little more subtly a second ago, but you must not have caught it. The magnitude of the other one is the square root of these. Has somebody already found that yet? Okay, if you haven't already, go ahead and find those. That magnitude will go here. And the dot product, in case you're wondering which one to do the dot product for, because we got like a point here and a point there, and we got, you know, all these things to do dot product of, you use these. Do the dot product of this and the dot product of that. And then at the end, you'll have to do inverse cosine to solve that. All right, so there's some hints for you. I'm going to pause for a minute and let you finish that up. So, when you solved, did you notice that t kept coming up? Like, for instance, on this one, t came up to what? 8. And if you did it for the next one, surprisingly, t would come out to 8 again. Okay, so if I put in an 8 right here, 2 times 8 times 4 is 32, plus 2 makes 34. And then I put an 8 in here, and that becomes 24 plus 10 is 34. It always works. 8 works. So what does that mean? Time is 8 when what? When the planes meet. The planes will hit at time equals 8. Where will they hit? That's not that hard. If they're happening at time equals 8, all you got to do is take either equation, because they're both going to hit the same point, right? And then I stick in an 8 here, and I figure out where you are at time 8. Yes? Why do we want planes to crash? We want to know when they would intersect. So actually, if you know when they would intersect, then you can intervene and stop it from happening. All right, so the position of Q is just simply -5 plus 8 times 4, so, and etc. And you do that for either. In fact, to really check yourself, you should do it on both equations. You stick in an 8 for both of them, and hopefully they come out to the same exact point for x, y, and z. And what was that point? 27. There we go. That's the spot that they meet at time equals 8. All right. Now, how could you make this more difficult? Well, this really, now that you're done with it, I hope you see that it really isn't that hard. You're just setting some equations equal to each other. It's just that it's hard to visualize. So what if the 2 points, I'm going to put this one back up here again. What if the 2 points were far enough, what if they were heading in opposite directions? Well, opposite directions, they'd never hit each other, right? Okay, so they're heading out and they're going to hit over here in quadrant 1 and out towards you. It's interesting. It brings up now there's not quadrants anymore. There's 1, 2, 3, 4, there's 8 zones. Okay, so anyway, it's going to, let's say that they're going to meet over here. And the one's flying over here, the other one's flying over here, and they're going to meet there. What if one of them's flying twice as fast as the other one? Could we make it so that it's twice as far from it? And still they're going to meet? You get how if it flies twice as fast, but it goes twice as far to get to the point? So do you agree it's a lot closer to this one? Now I'm closer to the pink one than I am to the yellow one. In fact, I might be like, well, 3 times, at least 3 times as far. this distance compared to that distance at least 3 times as far. So then the other one would have to be traveling at a much faster rate to be able to get to this spot if they're both flying to that spot at the same time. All right, so all I'm saying is it worked out really nice where the time was the same for both of them. What if I make it so that this is lambda and this is mu, and they're different, and therefore they come out with 2 different things? Then when you set your little equations equal, you'd have 3 plus 3 lambda equaling -5 plus 4 mu. And that equals that doesn't just instantly solve itself and get 8. Okay, we did one like that the other day. We have to set that equation along with another equation, the next one, 2 plus 4 lambda. And the next one here, 10 plus 3 mu. And now I have 2 equations, don't talk, that equation and this equation. And I can then set, if I have 2 equations and 2 variables, I just plug the one equation into the other equation. That's what you're going to need to do for your homework for tonight. So you have 2 things to do. Number 1 is there is a homework assignment in here, or a homework problem in here about cars. I thought instead of doing 3D for both problems today, we do one about cars, which is back to 2 dimensions. Okay, so it's a little bit easier. Okay, so that's the first one, is number 1, and it's got like A, B, C, D, and E. And it's just breaking the problem up into little parts to help you do it. Okay, so that one, it says that it's a 10-minute question. So it's a good, challenging question, not impossible by any means. This is doable. Moving on to, here's the one I want you to also do. You're going to need to write this one down. Okay, you have 2 planes. Here's the equation for the first plane. That's where it starts. This is its speed. And this one, actually it's not its speed. This is a counter that's going to tell you after I put in 1, it'll tell you where it is after 1 second. Or let's do time is in minutes and the unit is in feet. Okay, so it's feet and minutes. What? Okay, on to the next X, Y, Z. This is plane number 2. This was number 1. This is number 2. And plane number 2 starts at this point, -8, 1, and -2. And it goes with this. It goes every count, every click, it goes 5, 0, and 2. That means it's not moving at all in the Y direction. Is that possible? Yes, it is possible. Like I can stay here. If I stay on this line right here, I'm not moving at all in the Y direction. And if I stay on this point here, I'm not moving at all when it comes to X direction either. If I stay right on this line, what am I moving in? Just the Z direction. So I'm still moving, just because it says 0. I'm just moving 0 in that direction. Okay, so here's my 2. And notice, one's lambda, one's mu. And you can solve them the same way. You're just going to have to take an equation for this one, like 1 plus 1 lambda. And then you'll have this one, 8 plus 5 mu, and set them equal to each other because your x's are equal. These will touch at a spot in space. You have to figure out where they touch in space. And you'll have to figure out, it's not just like time 3. Okay? You're an honors pre-calc. You can get past, you can go further than that. It's one of them's going to be at like time 9, and the other one's going to be at like time 7. And what does that mean? If one's going to be at that spot at time 9, and one's going to be at that spot at time 7, what does that mean? They won't share the same space at the same time, and therefore their paths cross, but they won't actually hit. So where would they have hit, and when would they have crossed that spot? All right, 2 homework problems for tonight. The one I just gave you, and problem number 1. That's all I got for you for today.